Greetings, Professor. So, the first question which we were given was the difference between uninformed and informed research. So, uninformed research is basically blind search, and in those the algorithms which are there, they explore the search space without having any domain knowledge beyond the problem, what the actual problem is. So, beyond the problem definition, they don't have any other domain knowledge. They only know the structure of the problem and expand the nodes systematically according to that. Whereas, so for examples, for the uninformed search, we have breadth first search, depth first search. And then if you're talking about the informed search, that's the heuristic search. And in these, the algorithms, they use heuristics. For example, the one we will be doing right now, the A star, that's informed search. And they combine cost as well so far with the heuristic estimates. And our second question was, what is heuristic? So heuristic is a function that estimates the cost of the cheapest path from the node n to any goal node. And it's not guaranteed that it'll be exact, but it provides us guidance to what we have to prioritize, and it reduces our search effort. And the third question was, when is a heuristic admissible? So, when do we know that the heuristic is admissible? First, it cannot be negative. And the second, if it never overestimates the true cost of reaching the point from node n to, to the goal node from node n. So, it cannot overestimate that. Um, and then our fourth question was, it's F, and the 2 is the heuristic, and we have to find the cost. So Fn is equals to 5. Here it is. 5 equals cost plus 2. So cost becomes 3, but that cost is not the cost from C to F, rather, it's the cost from A to F. So for finding the cost from C to F, we do 3 minus 2. So 3 was the cost we had actually found, and 3 minus 2 would be the cost for C to F. And this is the exact same way I have done everything else. Um, and then our sixth question was to actually, sorry, the fifth question is the heuristic admissible? So, first thing, it proved that none of the heuristics are negative. So, yes, the heuristic is admissible because none, so first condition is proved. Secondly, it can never exceed the true cost to the goal. So in this case, it can never exceed the true cost. So if you're going from A, C, E, if you're taking the true cost, that's 3, and H of A is also 3. So it can be equal to, but it cannot exceed that. And if you're taking it at C, the two true cost via, so if you go from C to E, the true cost is 1 and the heuristic is also 1. So that is admissible in that case as well. And at E, if we are taking, that's the goal node. So the heuristic is 0. And at B, D,